In this video, we look at frequency tables and what we do to analyze the data. Before we do that though, let's have a look at what sort of information we present in frequency tables. Now, whilst frequency tables aren't exclusively used for categorical data, that's probably the most common area we'll see in the examples and certainly the ones we've got coming up in this video. And that's data that belongs to a group or category. One possibility could be hair color, so we're talking about people with blonde hair, black hair, etc. Another example could be movie genre, in other words, the type of movies that people like best. No doubt there are many other examples, but most of the time the responses are not necessarily numerical. Let's go back to our frequency table that we've got here for Year 11 and 12 students and their preferred transport mode to get to school. When we look at each of these rows, we can form a total, in other words, the total number of Year 11s. In this case, if we add all the numbers, it comes up to 139. Likewise, we can form a total for the number of Year 12s, and that total comes to 105. Looking down the columns, we can also form a total for the favourite transport mode. So we can see we've got 30 on the bike, we'll have 92 that catch a bus, and we'll have 67 that get a lift in a car or drive a car, and there's 55 that catch the train. And there's an overall total as well, and that usually goes in the bottom right hand corner, and we can see the total number of students that we've surveyed here is 244. So how do we analyse this data? The question we might be asking is, does being in a certain year group influence the type of transport that you use to get to school? And it's a bit difficult to do that when we've got different number of students in Year 11 and 12. What would be a good idea would be to have some percentages. So to show this process, we'll start off with the row percentages. This means we're looking at the row of students in a particular year group and we're working out what percentage within that year group took the different modes of transport. So we'll start off with the Year 11s and we'll work out how many students there were in total. We previously saw that was 139. And now what we're going to do is work out the percentage of students in Year 11 that take each of the transport categories. So for bikes, it's 25 out of 139 multiplied by 100. And we'll continue that process with all the different numbers. Once we've completed that row, we can now see the percentages for all the different transport categories in Year 11. And if we continue that for Year 12s, we can start to make some valid comparisons between the year groups because both of those values will be out of 100%. So now looking at Year 12s, we adopt the same principle. We look at the total number of students in Year 12, which is 105, and to work out the percentage of students that took a bike, it would be 5 divided by 105 multiplied by 100. So we get a percentage of 4.76, or rounded to the nearest whole number, 5% of students in Year 12 take a bike. We can do some more percentage calculations for the other modes of transport in Year 12 to achieve these percentage totals. Now what's interesting to note is that even though those percentages, when left accurately, do add up to 100, when we round them off, the percentages in the Year 12 row add up to 101. Now that's not unusual, and that's because there's an error in rounding. So we can say that each of those rows effectively still adds up to 100%. Now let's have a look at how we do column percentages. It's the same thing, but what we do is we look at each column, add up the total for the column. So for example, in the bike column, we can see the total there is 30. And we then proceed to calculate the percentages by saying, for example, in Year 11, 25 out of 30 students ride a bike, so we convert that to a percentage, and that's 83% to the nearest whole number. Then for the Year 12s, we work out what 5 out of 30 is as a percentage, and that comes to 17%. Now it'd be wise to pause here and see if you can work out the column percentages for the bus, car and train, and see if you agree with our results coming up. So just to remind us what we're basing our column percentages on, here's the frequency table, and the results that you should have got for the different columns are shown here. So that completes the column percentages. But which one do we use out of the column or row percentages? Is there a trigger that tells us which one's the best way to go and what's the reason why we actually do it in the first place? Well, what we need to do is identify out of our two variables which one's the explanatory variable and which one's the response variable. Some people often call them the independent and dependent variables. So what makes a variable an explanatory variable? Well, first of all, let's identify what our variables are. There's different transport mode and there's year groups or age. So the question we're actually asking is, does a student choose a transport mode based on their age, or do they choose an age based on their transport mode? So thinking that through logically, it's quite likely that a Year 12 student will probably change to driving their car because they're at an age where they have their license. It's unlikely that a student will catch a particular mode of transport like a bus or car and because of that choose their year group. So the year group influences the transport mode, not the other way around. So we call the year group the explanatory variable and the transport mode is the response variable. In other words, we respond with a transport mode based on which year we're in. So because of the setup of our table, our explanatory variable, which is the year group, goes across the table. In other words, we look at the row percentages. And what that tells us when we compare the percentages, we can see down each of the columns that there's a clear increase in the percentage of students who drive a car to school. We can see that from year 11 to 12, it's increased from 13% to 47%. So it does appear as though the year group does have some influence on the transport choice for students. Alternatively, there may be tables where we can't see much difference between different values of the explanatory variable. In that case, we can't say that a particular year group would affect a mode of transport. Fortunately, in this case, we can see a significant contrast in the percentages, and we can make a judgment that the year group does appear to influence students' choice of transport.